Respected Dr. G. Ganapathy, the resource person of the day. Mrs. Chandra Devi Thanikachalam, Chairperson, Ethiraj College for Women. Dr. S. Kodai, Principal. Dr. D. B. Usha Rani, Principal in Charge. Dr. T. Usha Priya, Vice Principal, Self-Supporting Stream. Dr. R. K. Maya, Controller of Examinations. Heads of various departments, Dean of Students, faculties and students. A very good morning and a warm welcome to one and all present here to the webinar on disaster risk reduction and challenges organized by Disaster Mitigation League, Ethiraj College for Women. Now, I invite Dr. Archana Soman ma'am, the Faculty Coordinator of Disaster Mitigation League, Ethiraj College for Women, to introduce the resource speaker of the day. Thank you.
Thank you. So, good morning, everybody. It's my proud privilege to introduce Dr. G.P. Ganapathy, the resource person for the day. Dr. G.P. Ganapathy graduated from the College of Engineering, Guindy, Anna University, Chennai in 1997 and completed his master's from the same university in applied geology discipline. He completed his doctoral research in earthquake microzonation for Chennai City at Anna University, Chennai. He has served for the Center for Disaster Mitigation and Management, Anna University, Chennai, for about 8 years as a scientist and carried out research studies in the field of earthquake hazard management, earthquake monitoring, seismic microzonation, landslide hazard zonation, liquefaction hazard mapping, soil bioengineering for slope stabilization, environment impact assessment and management. Later on, he moved to the Center for Disaster Mitigation and Management, Vellore Institute of Technology, Vellore, Tamil Nadu, India. Dr. Ganapathy served as Director for Center for Disaster Mitigation and Management, Vellore Institute of Technology, since the year 2015 to 2020. Sir has published 60 research papers in reputed international and national journals and presented more than 45 papers in international and national workshops and conferences. And he is the managing editor and editorial board member for 8 international journals. Dr. Ganapathy has created awareness on disaster education, space applications in disaster mitigation and management to the public and to the scientific community across the globe through various lectures for the past 13 years. He has visited 10 countries, including the United States and Europe, and presented various lectures on disaster mitigation and management. Dr. Ganapathy is the point of contact in India to the University Space Engineering Consortium Global. He is a member of the State Disaster Management Plan Core Group, State Early Warning Committee member, and consultant for preparation of district-level multi-disaster plan, Government of Tamil Nadu. Dr. Ganapathy is the nominated member of the Disaster Management Agency, Vellore District. He is also the member for District Environmental Appraisal Authority for both Vellore and Tiruvannamalai districts. He is a member in the Drought Monitoring Authority of Vellore and Ranipet district. A district expert committee member in the major hazardous industries and member for District Wetland, South India for Disaster Management and member in many scientific societies. He is the nominated member for the creation of Disaster Laws Database for Tamil Nadu State by UNOPS, Geneva. Dr. Ganapathy is the invited member of Working Committee on Landslide Hazard Mitigation, formulated by the National Disaster Management Authority, Government of India. He has contributed to the Global Assessment Report 2011 on disaster risk reduction. He offered technical support in 2 major publications published by the Government of India. That is one, the Seismic Microzonation Methodology, and the second one, Landslide Hazard Zonation Atlas of India. Dr. Ganapathy has received special award for the contribution to District Disaster Management Authority, Vellore, and received various fellowships like the United Nations Office of the Outer Space Affairs, Vienna Fellowship, INAE Fellowship for mentoring faculty in landslide disaster risk, International Network of Crisis Mappers Net ICCM Fellowship in 2016, and so on. Sir has handled 14 funded research projects and more than 30 consultancy projects on disaster mitigation and management and mining. His recent funded research projects and monitoring Natural Hazards in Mountainous Areas of Russia and India, funded under Indo-Russia bilateral collaboration and appraising risk past and present, interrogation historical data to enhance understanding of environmental crisis in the Indian Ocean world, funded by Social Science and Humanities Research Council UK. At present, Dr. G.P. Ganapathy is working as professor at Center for Disaster Mitigation and Management, Vellore Institute of Technology, Vellore, Tamil Nadu, India. Sir, we are proud to have you with us, sir. May I now request you to take over the session?
Thank you. Are you able to hear me, right?
Yes, sir. Yes, sir.
Okay. So, respected Chairperson Dr. Chandra Devi, Ethi-Shakthi College for Women, and the Principal Dr. Kodai, Ethi-Shakthi College for Women, the Deans of Students, Dr. Punita Devi, Dr. Anusha Balasingh, and Ms. Arna from the Faculty Coordinator of Disaster Mitigation League. First, I would like to thank Ethi-Shakthi College for Women to give this opportunity to present on this disaster risk reduction and challenges in front of the wide audience. I could see like more than 100 students are there here, students and faculties, and thank you for the very good opportunity. So Ethi-Shakthi College, actually, when I studied in Anna University, we used to visit sometimes over there for some programs. I still remember whenever I cross over Egmore, we used to see this college. It's one of the very renowned college. I think it is founded in 1948, I guess. So one of the very old college in Tamil Nadu, particularly in Chennai. Very renowned college, and really humbled and honored to be presenting a lecture over here. Thank you very much for calling and presenting a lecture. I would like to share. Can I share? Yeah.
Yes.
Yeah. Are you able to see my screen?
Yes, sir. We are able to see, sir.
Yeah. Okay. So today I'm going to talk about the disaster risk reduction and challenges. I think I was go through your website, like, a lot of your students, you have programs on science, commerce, and humanities and management and mass communication. So generally, we used to teach for engineering students here. But I would like to a little bit change the topic over the other side. So I'll be giving some basics since this is the disaster mitigation lake program. So what I thought, like, I can give some basics, then later I can move to my lecture on the challenges what we have in disaster risk reduction, particularly in our India. So so let us go back to history. We had huge number of disasters which is affected. Like, nowadays we are telling, like, we have disasters. A lot of people, they died. A lot of infrastructure damage. All these things we are talking. But what I want to convey is, like, we have disasters in the past also. So this is in the year 1138. Aleppo earthquake. This was in Syria. This was situated in northern portion of Dead Sea, and it is separated by the African plate and Arabian plate. There were around 2.3 lakhs people died because of this earthquake. And this is in the year 1556. There were around 8.3 lakhs people died in China. A Shanghai earthquake, what we called. So more than this happened in 23rd January of 1556. Around 8.3 lakhs people died. And this is 1642. Kaifang flood in China. There were around 6 lakhs people died. So nowadays, everywhere we see, a lot of floods are occurring all over the world due to the climate change and other effects. But the death toll due to floods are very, very minimal. But in those days, in 1642 itself, the death toll is somewhere around 6 lakhs. You just imagine what is the situation over there and now. So this is 1737, Calcutta cyclone, what we call. Again, 3 lakhs people died. And this is 1876, 1878. There are around 3 lakhs people died because of the famine. So famine, this is a new word, I think, to many of us. But it's a very, very important word in those days, like, because of lack of food and malnutrition. So many people died all over the world. Those days we called as Madras, Mysore, Hyderabad, all these things in southern part of India particularly. We have more than 3 crore people, they died because of this famine. And this is 1839, Koringa cyclone. Koringa, this is in Andhra Pradesh. Again, because of the cyclone, we had 3.2 lakhs people died. And this is 1918. More than 7.5 crore people, they died because of this pandemic, flu pandemic. So right now what we have, we talk about the COVID and other, variants. But in 1918 itself, we had this kind of event which has happened, and more than 7 crore people, they died. They said it is infected 3 to 5% of the whole population of the world in those days. And this is 1970, again, Bola cyclone. Those days, they called us Pakistan, but this is in part of Bangladesh. There were around 10 lakhs people, they died because of the cyclone in Bangladesh. And part of India also get affected by the cyclone. But if you go and see now in Bangladesh, Bangladesh is 200% prepared for cyclone kind of things. Like the recent Bangladesh cyclones are, even we can say like the death toll is somewhere around 0. And this is 1975. We had a dam failure again in China, Bangkok. Again, 2.31 lakhs people died. In 1976, Tangshan earthquake. Again, 2.42 lakhs people died. In 1981 to 1984, 20,000 people died due to African drought. And 1993, Lathur earthquake, which has happened in southern part of India. This is one of the deadliest earthquake which has happened in peninsular India, what we called. In those days, we used to believe that peninsular India doesn't have any earthquakes. But it hit over there in Lathur and Muswanabad area, and more than 20,000 people, they died because of this earthquake. And this is Orissa super cyclone in 1999. So that day, that time itself, somewhere around 10,000 people, they died. And more than 2,75,000 houses was destroyed because of the cyclone. And if you go and see now in Orissa, most of the people, they are well prepared, and the whole Orissa state is well prepared for this kind of, cyclone situations. And this is in 2001. You all know Bhuj earthquake, what we called this Republic Day earthquake of January 2026 January of 2001, which has happened almost 21 years back, and the death toll is somewhere around 20,000. And this everyone knows about 2004 Indian Ocean tsunami. We have more than 2 lakhs people died. And 2013 we had Uttarakhand flood. Somewhere around 5,000 people died. And year 2014 we have a Kashmir flood. We have more than 500 people died. So what I want to convey is, disasters are there. It is not new to us. It is there globally. It is not only in India. It is there globally. So none of the part of the world is free from disasters. So everywhere we have disasters. So what we need to understand is, in those days, the death toll due to disasters are, very high. But in nowadays it is reduced because of the new technological advancement in disasters. But the infrastructure damage and the preparedness, what we are doing currently, is there significant or not? That is a big question, what we have currently. So we have to think about, how, our disaster risk reduction strategies are there. So in that concept, in that connect, I would like to talk about, what are the major challenges, what we have in India particularly, and, what kind of, activities we are doing already. And still we have many, miles to go in particularly in disaster mitigation and management. So I would like to talk something initially the basic things on disaster, because, it's like, treating a patient. So disaster management is a very vast area. So we need to have different, kind of people involved in it. We need to have a science people, we need to have engineering people, we need to have a commerce people, we need to have a humanities people, we need to have a management people. So it's not like a one-man science. So it's a multiple, area of expertise what we need in disaster mitigation and management. So what we need to understand, first we need to properly understand what a disaster will do, right? So we have two kind of disaster. One is slow onset, other one is rapid onset. So slow onset disasters, like some of the disasters are slow onset. It happened very slow. Maybe a cyclone. You have a 10 days time to mature a cyclone. We can able to predict a cyclone. Rapid onset. The rapid onset in the sense like some events like earthquake. It happened within very quick. We don't have time to even predict. So suddenly it may happen. So why it is important? Because this will give an idea like how we can prepare before and after the disaster and even during the disaster. So the slow onset event like cyclone, we have quite enough time to prepare for a disaster. But the event like earthquake, we are not able to plan anything for a earthquake situation. So we can try to manage those disaster by doing some kind of mitigation efforts, whatever we can try to do. And another one is the frequency versus severity. So some of the disasters we have very frequently, like flood and cyclone, which is happening every year. And like earthquakes, the severity is very high, but the frequency of the earthquake is very less. So in any case, like the earthquakes, if you want to have a bigger earthquake, we need to have 100 years or 200 years return period. So the time will be like very less in case of frequency of occurring in disaster like an earthquake, but the flood and cyclones we have every year. So it will give a lessons like we can understand. So every year when we get affected by a flood or a cyclone, we are trying to do something and we are trying to manage this disaster. But earthquake, which has happened 100 years once or 200 years once, because of that, like we worked during the earthquakes, then after that we forgot about earthquakes because we are not having a bigger earthquake. So we forgot about earthquake. We are not trying to monitor or do any other activities. So this is also another important challenge is what we have. And another one is like mitigation measures to withstand impact and avoid impact. So if you see this map, like this is called a seismic zonation map of India. So we can identify the areas, like we can assess the areas, which are all the areas in India. We have earthquake prone areas. This is one way we can try to go for our mitigation measures, like wherever we have zone 4 and 5, we can go for earthquake resistant buildings. So then we can try to mitigate to even though there is an earthquake, if our buildings are safe, then we are not much worried. Or if you want to do avoid impact, like we can go for avoid bigger structures in high earthquake prone areas. That is also possible that we can do. And the study area in the sense like the earthquake in an urban area and earthquake in a rural area. Say example, in 10 square kilometer area, urban area, we have thousands of buildings. In the same 10 square kilometer area, in a rural area, we have very less number of buildings. So the area is same, but the vulnerability is very high. Vulnerability in the sense like the buildings, the persons, what we have. In the same area here, in a rural area, it is only maybe around 10,000 people. In the same 10,000 square kilometer area, in city area, we have more than 10 lakhs people. So the vulnerability is increased. This is also another one important thing, like, we have to discuss about, particularly the main challenges what we have in disaster mitigation and management. Okay, let us start with a basic definition of disaster. So what is a disaster? We have many definitions are available in the internet, but this is the standard definition which is given by UN ISDR, United Nations International Strategy for Disaster Risk Reduction. The impact of a natural or man-made event upon a vulnerable community, resulting in destruction, damage, and casualties, which cannot be relieved by the unaided capacity of locally mobilized resources. It means if it is not possible by the locally aided resources, when we are calling assistance from the other agency, then only we'll call it as a disaster. So that's why, like, generally in any cases, like, our state government or central government, when some disaster happens, they don't announce it's a disaster immediately because they are trying to manage. So if they are not able to manage, then only they'll call for assistance. So that's why the disaster is a very important terminology, because if the chief minister of the state is in charge for disaster management, if a chief minister says I'm not able to handle the disaster, he or she should resign his job actually. So that is the one seriousness is there in disaster. Like if any country is not able to handle a disaster, so if they're not able to handle, then the country's representative should resign his job. So that kind of policy was there in disaster management. It's very, very serious concern. So the same thing which is happening in Haiti also, the Haiti earthquake, which is not the president of the Haiti is not able to handle. So they had a serious issue after that, disasters. Okay. So what are the important community needs? We need to understand what a disaster will do. Whether the ground will, say example, if there is an earthquake, whether the ground will open, all will go inside. No, even though if you are going to have 8 or 9 magnitude earthquake, it is not going to happen. So what a disaster exactly will do, what an earthquake will do, what a flood will do, what a cyclone will do. So we need to understand. So I'll just give some example later on that. And the best immediate action to take personally and by the families and the kin groups. So what are all the things we can do? Because individually what you can do, so what kind of information you can gather and what kind of information you can disseminate during a disaster and after a disaster, that you have to plan. And how best to help the other members of the community. Suppose if you are working in a group of people, in an area, group of area, like, how you can try to help the others. That is also important one. And what government has planned. So government has certain restrictions. So you cannot, expect everything from a government. Say example, when there is a flood happen, a lot of cattle might be died. So if you want to get a cattle loss, you have to take a photo of that cattle loss and show it to the government. They will give money, but again, the money is restricted. Like, for example, if you, show a photo of dead chicken, so they'll show like, they'll give only 50 rupees for that. And again, if a goat is died, then they will give some 100 rupees or 115 rupees like that. So like that only, they have restrictions. So they are not able to give, even though a goat costs somewhere around 5,000, 10,000 rupees, but you are not able to get full money. So government have some restriction in funding, so you cannot expect everything government to do. So that is also another important thing. And how to participate effectively in disaster communication warning process, because this is very, very important nowadays. Like, everybody, they started using social media in dissemination, but you need to know what is right and what is wrong to disseminate the information. This also I will show something like, how we are doing this and how to improvise shelters until sustenance and until assistance is available. So you can prepare your own shelters. That also you can have a idea how to do that. Okay, so this is nothing but the disaster management cycle. This is divided into two. We have a pre-event, we have a post-event disaster. So when there is a disaster happen, immediately after the disaster, when we call, like, we used to go for the quick response activity. That's what we call emergency. All right. So the emergency and all disasters can be considered as to be an emergency, but all emergencies cannot be a disaster. So when we talk about the immediately after any disaster, rescue is the main thing. Like, in disaster situation, it is a quick response. You have to do quick response. The main challenges what we have in rescue operation is the trained person for rescue. For example, you all know there is a building collapse in Maulivakkam in Chennai. When it happened, it has happened by the late evening. By the time the fire and rescue people came, police came. So the rescue operation was undergo somewhere around 4 to 5 days to rescue 27 people. So totally 40 people, dead bodies we recovered, and 27 people, only victims, we are able to rescue. So to rescue this 27 people, somewhere 700 to 800 people were, involved in this time. During that time, I was there actually. Even the chief minister that time, Dr. Jayalalitha was there. All IAS officers were there. Fire department there. NDRF, National Disaster Response, was there. So the main challenge what we face is the nighttime rescue. Also the building collapse. It is not an earthquake. It is simply a building collapse. It's an 11-story building which is collapsed. So rescuing a person from a debris is a very, very tough task, particularly the concrete debris. The removing concrete debris, we had a major challenge during that time. So it took somewhere around 4 to 5 days to rescue all 27 people during that time. And after the rescue operation, we have to do the relief operation. So relief also, we have a major challenge. Nowadays, everybody is seeing, even in 2015 flood, while distributing relief, we faced a lot of challenges. Actually, we had a big group of people. We worked, with the help of other, social workers. So distributing relief is a major challenge, what we faced during Chennai flood, because everywhere there is no power. So going to another place is very, very big challenge, because Chennai, everywhere water is filled during 2000 Chennai flood. And the relief materials also, we had a major challenge. Many of the cases, what we face is giving this relief material is a big challenge. What we faced is a male relief worker not able to give a female relief worker, say example, a sanitation pad is a big need during the Chennai flood. Actually, we sent with some male volunteers, but the female victims, they are not able to receive from the male volunteers. So many kind of issues we faced during Chennai flood. And relief operation also, many kind of other challenges, like say example, in 2015 Nepal earthquake. We were there in Nepal after the Nepal earthquake. We are trying to help people. One full lorry, container of lorry medicine came from German. So the big challenge what we faced is a lot of medicine came, but we are not able to read the medicine's name, because the doctors, when they read it, it's sourced in German language. So we face a big problem to segregate these medicines. So what happened after that, we asked some IT people, we asked some computer software people to create a software and try to translate by creating an app, try to translate these medical scripts and distributed after that. So these kind of major challenges what we face during relief operation. Also during 2001 Bhuj earthquake, actually we reached Bhuj after second day. In the morning time, they were distributing a lot of relief materials like dresses. So in the evening time, when we go for assessment, a lot of people, they throw this dress material in the roadside. When we ask these people, they said I asked one of the Gujarati person, so why you are not wearing this dress? He said the climate of Gujarat. So I said, I don't know. So daytime we have very hot and nighttime we have very cold. So we used to have a long dhoti kind of things we used to wear in our head and work in the farm. And the nighttime same dhotis we used to have a blanket. But you are distributing some jeans and t-shirt, but it is not useful for us. So even giving a relief material to a particular kind of community is very, very important. People, they are ready to accept whatever you give. And also distributing food as a relief material. Many people I used to see during 2015 flood also, a lot of people, we used to send dosas and so nobody ready to eat dosa, because dosa, the dosa main problem in preparing a dosa, it takes minimum 6 to 8 hours. You have to have a wet the ural dal, rice, and mix it and keep it for better for 3 hours or 4 hours. Then tomorrow, the next day morning only, you have to take it in a pan and put a dosa. And if you want to eat dosa, you need to have a chutney or sambar. So you are taking some 12 to 13 hours to prepare this. And ultimately, when dosa get chilled, nobody is ready to eat. Even it is a disaster time. So we need to give a food items whenever I visit Philippines, I used to see a lot of food materials which is available in any auditorium. Whenever I go in the corner of the auditorium, there is a small room. They used to keep some kind of food material. I used to ask, what is this food material? It's like a noodles, right? They don't wait for anybody else. They take this food material, put it in water, and they used to hot water. They used to eat the food. So it's a simple like a noodles, 2 minutes it will get ready. So because Philippines is the country where they have a multi-disaster, they have earthquakes, they have flood, they have cyclones frequently. So they know that it's ready for them. It is ready anytime it may come. So they are ready with food items. So the relief is the major challenge what currently we had in India. So this also we have to face. So after relief, then we have to go, the move to the next is recovery action, the reconstruction. So the reconstruction activity also should go together. And after reconstruction, we have to go for the mitigation measures. It's nothing but the risk reduction. What we do, right, is reducing the loss of lives. That is our main mandate in our government of India. What we call this pre-disaster proactive approach. What we call it, instead of spending a lot of money on rescue and relief operations, spend money on mitigation and preparedness. So that you can, suppose if you are spending 1,000 rupees on relief and rescue operations, spend only 300 rupees for mitigation and planning, so that all your balance 700 rupees you will save. So that is the main concept on pre-disaster proactive approach what currently India is following. And so before going into the detail, I want to give some highlight on the hazard, risk and vulnerability and exposure. So in a simple thing, I can explain. Suppose you are in a classroom, say morning 8 o'clock, when no one is there in the classroom. So if you have an LCD projector, if the LCD projector catches fire, what happened? So the room will burn, the table, chair and the fan may get burned, right? So what we call is hazard. It's a fire hazard. So when the fire hazard is there, when you people are there inside in the classroom, okay, so you people are the vulnerable group to the particular hazard. Okay, so if you have a fire extinguisher, so you people are exposed to a particular hazard. Okay, if the fire is very small, okay, what we are trying to do is, if you have a fire extinguisher, you can take the fire extinguisher, quench the fire. So that is the thing, you can able to do that. Okay, if the fire is very big, what we are trying to do? So we are trying to evacuate. The main idea of this is to reduce the vulnerability. It's nothing but, if, say, example, in this picture, there is an electrical switch box, this kid is there, if the kid is near to the fire, what we are trying to do, if you have a fire extinguisher, take the fire extinguisher, switch off the fire so that the kid will be saved. Or we are trying to remove the kid from the fire. So only these two options we have. So what we are trying to do in disaster risk reduction is reducing the risk of the life. So hazard will be there, earthquake will be there, landslide will be there, fire will be there, cyclone will be there. But what we are trying to do, we are trying to reduce the vulnerability. It's nothing but we are trying to remove, escape or manage this disaster from a particular hazard. So our life to risk is saved. So that's what we try to do this in disaster management. Okay, so before going into other details, the basic things in disaster, you need to understand something. Globally, what we are talking about is, so the HIAGO framework is one thing, we used to talk about, this is between 2005 to 2015, the world level, we have a agreement, and we used to talk about building the resilience of nations and communities to disaster. It means people should resilience to cope up with a disaster. That's what the main idea of 2005 to 2015. After that, we had a Sendai framework in Japan. We had a conference followed by the Sendai framework is the successor instrumentation of the HIAGO framework. So what we face now is to substantial reduction of disaster risks and losses in lives, livelihoods and health in the economic, physical, social, cultural and environmental assets of persons, businesses and countries. It means we have to reduce the loss. That's what our meaning. Earlier in HIAGO framework, we used to talk about the resilience, but now we are talking about the reducing the risk to the life. And we have 7 targets. It's nothing but, most of the targets is nothing but reducing the loss of lives in 2030 by 1 lakh people in death and 1 lakh people in mortality, in affected people. And you have to bring down the GDP, economic loss by the GDP in 2030, and substantially reduce the disaster damage in 2030. and increase the number of countries cooperation and enhance the international cooperation, and also we have to do the build back better. So this was the main idea of Sendai framework. We have 4 priority areas. Understanding disaster risk is one thing, and strengthening disaster risk governance to manage the disaster risk, and investing on disaster risk. This is not there currently in most of the countries. Like now, the government of India also like try to invest money on that. And the 4th one is build back better, because we have to quickly recover back from our disasters. Okay, so let us start with disaster management in India. What we have currently, like we have 2% of the world land area, but we have 16% of the total population of India. So this is one thing, like in a small area we have large number of people. So even though we have a moderate disasters, we have more people get affected. That is the problem with compared to other countries. Why India and China we had more problem, because we have huge number of population. So what we are trying to do, land mass is same. Okay, disasters are occurring. What we are trying to do is we are trying to reduce the vulnerability. How to do that? So before going into that, again, I want to discuss something like, what is the history of disaster management in India? We have a high-powered committee, which is set up in 1999. Until 2001, till Bhuj earthquake happens, it was with the responsibility of Agriculture Ministry. So after that, it is transferred to Ministry of Home Affairs in June 2002, because we need to have a lot of people to rescue. So military's help we need. So that's why they have transferred to Ministry of Home Affairs. So after that, National Disaster Management Authority is established. In 2005, we have a National Disaster Management Act is passed in the year 2005 December. After the 2004 tsunami happened, so this was the thing happened. And the National Disaster Management Authority is formed, and we have a NDMA. Under that we have National Emergency Center. Under that we have a State Emergency Operation Center, SDMA. And under State Disaster Management Authority, we have a DDMA, District Disaster Management Authority. So for example, NDMA, our Prime Minister is the chairperson. Our State Disaster Management, SDMA, our Chief Minister is the chairperson. For DDMA, our District Collector is the chairperson. So we are all one of the members in the district level authorities, for example. So this is the NDMA structure. You can find it on in any internet. And our Prime Minister's 10-point agenda, this is the one, like, right now in India, we are working on it. Like, we have a 10-point agenda. So all development sector must imbibe the principles of disaster risk management. Risk coverage must be include all, starting from poor household to SMEs, to multinational corporations, to national states. And women leadership and greater involvement should be central in disaster risk management. And like that, we have some 10-point agenda. Mainly, the develop a network of universities to work on disaster, because disaster management, if only the government is doing, there is no use. You have to institutionalize the Disaster Management Act. So that's why now the government of India, they are linking with all institutes under IUNDR programs, so that so any institute can join together with NIDM, National Institute of Disaster Management, for capacity building and other activities. Okay, so this is the NIDM, National Disaster Management Institution mechanism, and the state level disaster management coordination mechanism. And earlier we used to have one ministry to nodal ministry to handle the disaster, but now we have different ministry to handle. So accident, Ministry of Civil Aviation, accident by road, Ministry of Road Transport, avalanches, Ministry of Defense, biological emergencies, Ministry of Health, cold wave, Ministry of Agriculture, cyclones, Ministry of Earth Sciences, drought. So like that we have different ministries handling different disasters. Okay, so it's not like other countries, like India, we had our own classification of disasters. So our Prime Minister formulated high-powered committee. We have grouped the disasters into 5 major groups. One is water and climate related disasters, geology related disasters, and we have chemical, industrial and nuclear related disasters, and we have accident related disasters, and we have biological related disasters. So all this, we have more than 30 disasters in India particularly. So we have all grouped into major 5 groups. So these 5 groups are handled by different nodal agencies in Government of India. So you all know, our India is 57% land is vulnerable to earthquakes, 12% is vulnerable to severe earthquakes, 68% land is vulnerable to drought, and 12% land is vulnerable to floods. 8% land is vulnerable to cyclones. Apart from natural disasters, in some cities we have vulnerable to chemical, industrial disasters, and man-made disasters. So what are the things we have currently in India? We have a seismic hazard zonation map of India. If you see in this map, you can have, you can find it out, a lot of, faults are there. So we have number of epicenters over there in this map. So this is the one map which is useful currently for, we are under which zone? Zone 2, Zone 3, Zone 4, and Zone 5. Zone 2 is nothing but your least zone, and Zone 5 is very, very severe zone. And like that, we have a landslide hazard zonation map of India, actually. So here also we can divide India into number of zones, prone to landslide, unlikely, moderate to low, high, severe to very high. And we have flood hazard zonation map also we have in India, which are all the areas India is prone to floods. And this is the new map which is introduced by the Government of India, thunderstorm incidence map of India. And this is again a very important map, which are all the areas we have thunderstorms. And this is wind hazard zonation map of India. Yeah, and we have a cyclone occurrence map. So these are all the maps are already available. Okay, so let us move into the individual disasters. I will just quickly go through, earthquakes. Earthquakes don't kill people, but the buildings what we do, what we construct. That's what generally we used to say. Our buildings are prone to earthquakes. So everyone knows, we have a continental dip theory. Once upon a time, all the continents are, in a single continent. After that, it has split into a number of things. We have a convergent boundary, we have a divergent boundary. Because of that only, we had earthquakes. So this everyone knows about how the earthquakes are formed. But what I want to convey is, we have two types of earthquakes. One is interplate earthquakes, other one is intraplate earthquakes. So interplate earthquakes is nothing but when two plates are collide each other, we'll have earthquakes. That is interplate. And within a plate, we have number of faults. These faults are time to time, it will react. Based on that also, we'll have earthquakes. So these are all intraplate earthquakes. So interplate earthquake, we can't do anything because it's a major plate movement. So intraplate earthquake, what we can do, we can try to assess if in a particular area there is a fault is reactivating, and what is the maximum magnitude that fault can generate. So that is the one thing, what we can do right now. So yeah. So in ancient days, people, they used to detect earthquakes by using this seismograph. This is called Chinese seismograph. So there is a rod attached with this, each dragon, they have a ball on their mouth. When there is an earthquake happen from a particular direction, the ball will fall down. So based on that, they will identify from which direction the earthquake is happened. In those days, this is the thing, they used to identify how the earthquake happened. Then after that, they have analog seismograph. So this will work on a simple pendulum method. There is a wire and a ball. Then the ball will swing. Then it will record on a drum recorder. So now we have a digital seismograph, which is very, very highly sensitive. So this seismographs can easily sense even 1 magnitude earthquake also. So our technologies are advanced, and the one thing what I want to convey is earthquakes cannot be predicted as of now. So earthquake prediction in the sense we need to know which date, what time, where, and what magnitude earthquake is going to occur. So, but these instruments will help only after the earthquake occurs, it will detect. So far we don't have a technology to predict an earthquake. So, but important thing is many of us, we know only earthquake means there is a ground shaking, we all feel down. But it's not like that. Earthquake, it create multiple impacts. Main is ground shaking, and we have a liquefaction in the sense that soil will become solidified. So the hard soil will become liquefied. So the building will sunk, and faults, it will move one towards others. so that your building will collapse. So you have a land subsidence, like, if you already have a land area, if you have a lake area, if you fill the soil over that, if you construct houses over there, it will create land subsidence. Again, building will collapse. It will create landslides also. It will, if the earthquake is in the offshore, then you'll have a tsunami. And these things I'll skip. And yeah. So seismic zonation map, which depicts here is zone 2, zone 3, zone 4, and zone 5. We have a zone 2, it means 4.9. Zone 3 means 6.9. So it means places like Chennai, it is prone to moderate earthquake. We can expect a magnitude of up to 6.9. So these kind of maps will helpful to identify the areas where we have, how we are prone to earthquakes. But thing is, like, we have a Chennai city, this everybody knows, like this 1999 maps. And so these areas already, filled, and they have constructed houses over there. And what happened, what we called as site amplification. So if you feel one time in a hard rock area, in a normal area, if your building is feeling earthquake in one time, the same thing like places like the filled up soil area, you are going to get 2 to 3 times more. So that's why somewhere in Indonesia, if you have an earthquake, somewhere in Andaman, if you have an earthquake, you are feeling in Chennai city. So this is the one challenge what we have currently is the site amplification what we have. And we need to go for a lot of techniques are available to assess this, kind of information. Like, we have to assess the essential facilities, hospital, medical clinics, schools, institution, fire station, police station, emergency operation facilities, and high potential loss facilities like dams, levees, military installations, nuclear power plants, and hazardous materials. All these things we have to assess and see how the facilities were, safeguard from an earthquake situation. And lifeline inventories like highways, railways, bus, ports, and ferries and airports, and potable water, wastewater, nature. Because earthquake is nothing but the ground shaking. So our potable water and wastewater are all going inside the earth. So because of the earthquake, this may get disturbed and it may be get mixed with your normal groundwater. And natural gas and crude oil, it is stored in the ground most of the places. Like, if it is get mixed, and again you'll have a cascade effect of fire and other disasters. So this is the new technique which is available. Actually, this is what we call this rapid visual screening technique. So what we can do, you can identify whether your building is safe from earthquake or not. So suppose if you are in Chennai, you can do this exercise. There is a simple form is available here. If you have some basic knowledge in civil engineering, or you can consult with any civil engineer, you can check whether your building, if you are in zone 3, there is a fact sheet available for zone 3, zone 2, zone 4, everything. So from which location you are, you have to identify. Based on that, you can find it out whether your building is safe or not. So this is the technique what we use currently. So we used to do a lot of research on that. You can classify the buildings. Suppose if your score value is less than 0.7, it means like your building is not safe. So it is high probability of grade 4 damage. It means grade 4 means very heavy damage. So you can identify the buildings on its damage potential. And these are all the techniques are already available, what we call non-destructive techniques. So you can go for buildings damage potential, identify, and based on that we can do this. And we have a seismic building codes. We have a different building codes are available already. If you use this kind of building, even though you are prone to earthquake prone area, if you use, if you're any new constructing buildings, if you are using this kind of bands over there in the buildings, so that it will be safeguard. And if already you have constructed some buildings, so what you have to do, you can do this kind of supports over there from inside and outside, so that your building will be safe from an earthquake. And generally, how much cost is involved if you are going to construct a new earthquake resistant building. So if you are in zone 3, for example, in Chennai, so you have to spend 1.5 to 2.2% of your total cost of your building. For if it is a masonry building, if it is a RCC building, you have to spend 2.6 to 3.2% of the seismic resistance. And it is not enough to do this, like, because even though if you do for some kind of particular magnitude earthquake, but if there is a bigger magnitude earthquake, what you have to do. So this is the methodology we have used. Even though if you have a different magnitude earthquake, you can calculate. This is the new technology called hazard US, that we have converted into Indian condition, and we have done some work for Chennai city actually for different magnitude earthquake. If there is a 6 magnitude earthquake, what would be the damage? 7 magnitude earthquake, what would be the damage? And 8 magnitude earthquake, what would be the damage? That can be done by using this technology. And even you can say, like, which date your which facilities, like, schools or colleges will reopen, how much it is damaged, everything you can be able to calculate. So this, everybody knows about the safety of the earthquakes. We have a drop, cover, hold on action, but nowadays, like, we used to say, like, whenever there is a earthquake happen, you have to come out of the building. So because, places like Chennai and other things, we have a moderate earthquakes, so it is not going to be a major collapse, so we can easily able to escape from those earthquakes, so we can do that. And these are all some safety tips. Yeah, so this one I want to highlight, like, currently what we have is earthquake monitoring system in India, which is available. This is freely available in internet. You can find out, you can go to National Center for Seismology, and daily they are monitoring the earthquake. So today, if there is an earthquake happen, immediately they will plot over there and they will show, and you can find it out what magnitude earthquake happened. So this is a one thing, but still we have to go a long way in earthquake prediction, because this is not earthquake prediction, this is only a monitoring. So earthquake prediction is our major challenge. Like, if there is an earthquake going to happen, at least we should have a mechanism. So the earthquake waves next wave, when it is going to hit over our place. That kind of challenge with what we have currently in earthquakes. And we have floods. Everyone knows about the floods, but I will just highlight for a few minutes. And particularly on, we have a lot of work people they are doing for flood hazard assessment. The main challenge in flood hazard assessment is, like, we have different floods: periodic flood, flash flood, river flood, coastal flood, and seasonal flood. So now everybody they are talking about Chennai floods, right? Chennai floods. The major challenge in Chennai flood is, like, it's time to having a different kind of floods what we have. So you have to integrate all these 5 kinds of floods for mitigation measures. Otherwise, it is not possible to solve your Chennai flood problem, because Chennai have a periodic flood, Chennai have a flash flood, Chennai have a river flood, Chennai have a coastal flood, Chennai have a seasonal flood. So whatever we do, like, all our methodologies, like, scientists, they do, they prepare hazard maps by using only some kind of models, but that is not going to be useful unless you have to use some multiple angle, like, periodic flood separate assessment, flash flood separate assessment, river flood separate assessment, coastal flood separate assessment, and seasonal flood we have to do the separate assessment. Because flash floods occur, it's like a cloud burst. It can occur in suddenly. Say suddenly there is a last couple of weeks back, suddenly there is a heavy rain which has happened. So these kind of climate change effects are there in nowadays. So we are not including all these effects in our mapping processes. That is the major challenge what we have. And also Chennai has a urban flooding system. So you need to understand where you are and what kind of place where you are, whether in a main channel. So how much regulatory water flood surface elevation level is there, and where your building is constructed. So everything play a major role in flood mitigation. This is the major challenge what we have currently, because already a lot of people they occupied in 100-year floodplain area. So evacuating these people also major challenge what we have currently. And these kind of maps can be generated, like, probability of flooding, 5 years probability, 5% probability, 50% probability, and 95% probability of flooding. This kind of maps can be prepared, but a 100-year flood means, like, it can occur 100 years once in a bigger level flood. So you have to plan, like, all our planning maps, whatever currently the government is doing is 50 years or 20 years, planning. So it should be a 100 years flood, how much, maximum flood can occur. That area can be avoided for further developmental activities, and we have to have kind of risk mapping in that area, so that we have to go for the further assessment. And we have flood warning system. Again, this is also available in internet. You can just check over there. There is a flood warning system by the Central Water Commission. So all the dams are monitors over here. So they have to find out warning level, danger level, highest flood level. It is continuously monitored by the government. You can find it out where this data are available. If you click over there, how much water level is there, when the water is released, everything you can able to monitor. And so now all the district level authorities are preparing this kind of maps. We called Firka level maps. For example, this we have prepared for Vellore. Actually, it will give all kind of information, like who's the sub collector in that area, name of the designation authority, Tahsildar, and where is the location, where is the nearest shelter is available, what is the evacuation route. So everything can be prepared. This is already available in internet, and you can make use of it. This is for every district. They have prepared like this, and they just put it in the website. Again, what challenge we may have, particularly for flood, is like we are not combining all types of floods. That is the major challenge what we have currently. I think the government of India, the government of Tamil Nadu also, they form a group, and they are doing this work. And landslides, everybody knows about landslide. Landslide is a phenomena where you have a moving of soil or a mass in a slope. So you need to have a slope. So this is again major challenge. Like in landslide, is a lot of people get died because of landslide. Because chances of landslide vulnerability is like 0 or 1, what we call generally. The probability is because it is a moving of soil, so all soil will come down and it will cover over the building so that people are able to survive in case of a landslide. So in earthquake, even though there is a building collapse, the chances of saving lives is very high, but in case of a landslide, it is very, very less compared to. We have a different types of landslides. So we have again landslide hazard donation map like what we have for earthquakes. So these kind of areas already divided into areas unlikely, moderate to low, high, and very high. So the very high to severe areas, we have given a very close zonal significance also, what you have to do, what you should not do. All kind of informations are already available, but people, they fail to follow. And these are all some of the landslide which has occurred in Nilgiris in 2009. Actually, I was there. So main problem in landslides, it's a natural cause actually. What we can say, this is the slope. What we had a landslide in this particular slope. 7 people, they died. What they have done, they have simply removed the slope cut by doing some road cuts. If you see, there is a lorry, so you can see the height of the calculate the height of the slope. This lorry size 4 times of the lorry height. Generally, lorry will be 2 to 2.5 meter height, so 10 meter height, but the road it's only 3 meters. So the slope is very steep. So because of that, the landslide has happened. And also people, they divert the water. This is the original river water. They divert the water into some other channel without doing engineering measures. And also they construct a lot of buildings at the top of the building. It is added weight, additional weight on the top of the building. Because of that, the landslide has happened over here. And we have a lot of mechanisms now to strengthen the slope. We have engineering measures like sheet piling, geograde, drainage, so altering drainage water so that we can save, and trenching and benching. And this is the biotechnical slope stabilization. What we have currently is by planting a natural materials also, we can go for a mechanism. And again, slope stabilization by using soil bioengineering. This will give a very, very cheap things like if you want to treat this landslide, you have to spend crores of rupees. But if you do by using simple soil bioengineering, is nothing but by using of natural materials like bamboos and trees and bushes over there. And the people, they have done some slope stabilization by using natural materials. Almost they saved 1/4 of the money what they need it for. And we have a landslide monitoring techniques are already available by using artificial intelligence and by using sensors. So sensors will be put it on the slope, and it can give a warning so that before landslide happening also we can able to identify. But this will be helpful only for the shallow landslide. But we feel the landslide is very deep. We need to have an idea. It's very difficult to monitor currently, but government is working on it. We are also working on it. Actually, landslide monitoring we are doing currently with satellite remote sensing and other techniques. And cyclone and rainfall monitoring. India is one of the best country currently. What we are doing cyclone monitoring. So I don't want to tell much of this actually on cyclones. And yeah, so cyclone warning is already available. This kind of information you can get it in internet, or you can go to IMD website. Cyclone monitoring websites are available, so you can clearly monitor. So which date it start, how it is moving, and which path it is going to move, where it is going to hit. Everything we can monitor in cyclone monitoring. But major challenges here is again we so much of rely on artificial data, artificial intelligence and database. So when we do artificial intelligence data, a huge number of past cyclone data are available. But what many people they fail to do is they fail to understand the geomorphology of the area. So if you consider geomorphology also, then it's easy to predict your cyclone tracks, and particularly when it's moving to the land area. And tsunamis, if you have a earthquake in offshore, then you'll have a tsunami. And this also, we have a tsunami warning system. Currently, INCOIS is doing this. They have a buoys over there in the Bay of Bengal and Arabian Sea. So they have a very good monitoring system. So now we can able to predict tsunami before it occurs. We have 65,000 models are available over there our Indian Ocean system. Any part of the Indian Ocean or Arabian Sea or Bay of Bengal, if there is an earthquake happen, so immediately it will predict the wave motion, how much time it will take to reach the coastal area. It can be predicted in well advance, and people can be warned. And this is the warning system what we have currently. So automatically through satellite we get information. These are all the buoys informations are available over there in our Indian Ocean, and this is automatically picked and it will give information on that. And the government of India, they have a flood support system. We have a disaster management support systems are available. This is again available free of cost. You can find it out from Google. Actually, it's a ISRO website called Bhuvan. So in that it is available. So you can find it out which are all the areas are vulnerable to floods. You can find it out. And we have the National Flood Vulnerability Assessment Systems are available. Everything is free. Everything is available in online. You can find it out which are all the areas is prone, and you can see where you are and how much severity your area. Everything you can find it out. But the people, they are not much using of this kind of information. Also, we have a national database for emergency management system called NDEM. So this is one of the very best information system which is available now. But again, how many number of people in the world is, in India particularly, how many number of people in the India they are using, I do not know. But we keep on using to give early warning for the people by using social media. And this is another app. It is very much available. So everybody can download this app called TN Smart. Actually, our Tamil Nadu government is giving a lot of warning, weather forecast, satellite images, vulnerable. So everything is available. See, you might have seen, in Facebook and Twitter, so many people, they used to give warning. It is not their own product. So everybody, all the people who give information on weather forecast or any kind of monitoring is data downloaded from IMD website. It is freely available. They just go to website and they just look into different website and see what are the data available. Based on that, they will collect the data and they will put it in the social media. So it is not you don't need to be expert on weather forecast. What you need to know is whether it is right or wrong. That is the only thing you need to understand. You can just find it out from TN Smart or IMD website. It's very much available for all weather forecast data is available daily. Nowcast is there. You can district-wise nowcast is there. Even you can tell next to 3 hours when there is going to be a cyclone occurs. When there is going to be a rainfall occurs in your city. Next to 3 hours, 3 hours warning is very clearly given by the IMD website. So you don't need to wait for somebody to put information in your Facebook. You can go and see. Everything is available in online. And this is another one is called Indra Vajra. and Damini is there. And so these websites are very, very useful. You can predict lightning 15 minutes before. So it will give you information. You can check lightning which is going to happen in your area 15 minutes before. That is also very much available in internet. And another 5 minutes I'll finish my lecture actually. This is the one thing actually regularly what we are doing when Archana madam is talking about Crisis Mappers Fellowship. So actually we used to work with the International Crisis Group, a group of people. We work on different disasters. So the International Crisis Group we have a group of people from 42 countries. And whenever any disaster occurs in our area, we used to work together and we used to try to get help from others also. So what we used to try to do is nowadays, like, we get all the information, but those days we don't get much information from satellite data, but we used to get from UNOSAT. UNOSAT is the UN Operating Satellite System. So what we used to do, like, we have to trigger a query, like, when 2015 Nepal earthquake happened. So I triggered a query to UNAPS to ask the data about the Nepal earthquake. And what the UNAPS will do, like, they position the satellite to the disaster area. They have geosynchronized satellites. They position the satellite to the area, and they give us the raw data. Raw data in the sense, they give raw satellite data. So what we do, we used to analyze the data by using image processing and remote sensing and GIS. And we used to identify which are all the areas have high damage area. And we used to transfer this information. We have friends through this crisis mapper people. And also we have a local group who are working in Nepal and other areas. So we have Nepali people who are working in other countries also. So those people we used to link through internet and through a group of people, WhatsApp and other things. We used to disseminate this knowledge and analyze the data and send the information to the local people, to the NGOs, through NGOs in Nepal, and try to help them to do the rescue operation. So that's what I want to show something like what I have done during 2015 April Nepal earthquake. So we started monitoring Nepal earthquakes after it occurs continuously. We used to monitor like this from USGS website, and these are all the kind of satellite data you will get it. Like, if you see in the left hand side, this is a Google Earth image. In the right hand side is nothing but the DigiGlobe. DigiGlobe is actually the person who is supplying data to the Google Earth. Google Earth is not its own data, Google data. So somebody has to give data, satellite data to Google. Okay, so Maxa technology nowadays they are giving, and during those days, DigiGlobe used to give the data to the Google Earth. So what we do, like, we have a pre-data and we have post-data. So we can able to identify the same area. We can identify how many buildings are collapsed. So even we can find it out which are all the areas is totally collapsed, partially collapsed, everything. I don't need to go to Nepal. I can sit over there in my lab in Vellore and do this exercise. So even I can find it out how much area got affected, where to go, how to move, everything I can find it out from this area. This is what we did. It called rapid damage mapping. So people, they used to work only in city areas generally during this kind of disaster. So what we identify is the other part of the country also got affected, like Pokhara, Bhaktapur, Lalitpur, all these places got affected by the earthquake. So we identify, like, if you see this, map, you can find it red color and orange color and yellow color and green color areas are, highlighted by circle, by rectangles. So these areas are worst affected areas, like red color areas are worst affected areas. So satellite image will give an idea, like, how much damage which has happened. So we have to conduct this rapid damage mapping. In the right hand side, you can see, like, 2015, 29/4/2015. Every 1 hour data we used to get from the DigiGlobe. Actually, they give us special access to us during that time. I used to work from here in Vellore to identify the damage area. So this red color areas are total damage areas, and this areas we have to send it to the total destroyed houses, major and minor and affected areas. We used to map like this, and this data we used to send it to the local NGOs, and these NGOs will go to that particular place and they used to do the rescue operation in fast. So that's what we did during Nepal earthquakes. And these are all some of the high resolution satellite data we used with the help of CNS, and this is called CNS Airbus data from UNAPS. They give the data for us during that time, and you can find it out, like, if this is the road, so you can easily find out this road is blocked, so how to go to the via another road to the particular site. So like that. So this is the tomb which is collapsed and 180 people died over there. You can see how many number of people. I can even calculate how many number of people over standing over there in this area. Also we can calculate. So which are all the another alternate route to go to this area and rescue people. And this is another area similarly which is most affected. And also this is the stadium where we helped a lot of people from other countries also. They came to put a shelter over there and a medical camp over there. So we used to help people to identify what is the total area of this, how much shelter they can put it, and where they can go for the shelter, and where they can go for the relief material can be stored. Everything can be identified. I don't need to go to the Nepal. I can sit over there here in Vellore. I can do this exercise. So this is what we have done it. Actually, this is the places after Nepal earthquake. Actually, we identified the places. You can see this lot of open spaces are available. So all these spaces are filled up with, relief camps and medical shelters. So this we have done during even Kerala flood 2018 by using social media listening, what we call by Facebook, Twitter, and all these things people used to have. We have a key influencers, Jitesh Pillai, Nirmala Sitharaman, Shashi Tharoor, Tinu, because these are all the people, are authenticated people. So whatever they put it in Facebook, like by using hashtags. So these are all top mentions, whom they are mentioning this to CMO Kerala, PM of Kerala, Nirmala Sitharaman, ADGP, Dhanya Rajendra is a news journalist, and Indian Navy. So by using these hashtags, so we used to collect the information. We used to prepare the heat map. Heat map in the sense like, which area we have to concentrate, because these people are putting like, this is the area people get affected, and all this information we collect and we used to give the information. And this is what we have done during Nepal earthquake, Kerala flood 2018 also. How much area got inundated in different areas, how much, even crop got damaged, everything we can able to calculate. And this also we have done during Chennai flood 2015, which are all the area Chennai and Kadalur got, flooded, and inundation mapping we have calculated. Okay. So last 2 minutes I complete this my lecture. And one of the very, very important thing is transferring traditional and indigenous knowledge. So we have our own indigenous knowledge, particularly in Tamil Nadu, we have our own indigenous knowledge, which we are not using much. Actually, so what we have to do, we have to transfer our traditional and indigenous knowledge to our people. So this is one thing, like, in 2004, there is a small song in the sense like it's a song. There is a small kid, she sing the song before the tsunami, during the tsunami occurs. It means like when you sing the song, smong means you have to go to the lower elevation, to the higher elevation. So because of this song, a small kid in a village in Indonesia, she sang the song, so that all the people in that area, they evacuated, and the whole area got saved because of this song. So this is a very, very important message to us. Like in those days, like our forefathers, they have a very nice knowledge on disasters. So they teach us something, but we have failed to do that. But this has happened in 2004 tsunami. A lot of people get saved, and this is another one, like earthquake resistant traditional architecture in Japan. So there were around more than 1,000 earthquakes which has happened in this area. This is 1,300 years old temple. So none of the earthquakes has damaged this temple because of this. Temple structure is by constructed by using some kind of wooden balls over there, so that when the earthquake happens, it will shake but it won't damage. So these kind of techniques are already available in India. Actually, it was learned from India. The architect who came to India, he learned the technique from India, from Uttaranchal, and he go back to Japan and he implemented. But now we don't find this kind of structures over there in India. And this is another one is called baobab tree. Baobab tree is very, very indigenous tree. Actually, they use for the rainfall and drought warning. So if the tree trunk is very big, actually, because it can able to store water. So what happened during drought time? The bottom of the tree started drying. It means the whole area is the whole district is undergoing some kind of drought. The people of the village can able to understand they are undergoing some drought, so that they can do some mitigation measures over there. And another one is flood warning. Actually, this is a Mlaka belt in Swaziland. Actually, so what happened before a flood, 24 hours before a flood, the nest of the birds can be shifted into top. It means like there's going to be a flood occurs in this area. So a bird can predict there's going to be a flood in this area. It's like similarly like what we have our Situkurvi, similar kind of nest. So it will move the nest to the top of the area before it comes. And flood protection, this is called Vaju flood protection. They used to call in an area wherever they have a meandering of river. So wherever they have a river erosion, they used to put this Vaju plantation so that the flood protection will be there in the area. And everyone knows about the mangrove forest in tsunami protection area. So mangrove will stop, will reduce the velocity of the wave because they have a spinning roots, so that it will reduce the velocity of the waves. And this is called Sangakal Mandapam in Tirunelveli in our own Tamil Nadu. Everybody knows about this. Actually, our forefathers, they have a flood warning system like this. So when water increases through the conch, sangu, right, the water will go, the sound will go. Actually, the wave will go inside, and it will come out, and it will give an alarm kind of sound. And when water recedes, then the sound will come down, so that people will, when sound is increasing, people will go out of the river bank area. Once the sound is come down, then all people will come into the particular area. So this is another place, like wherever I go, I used to present this. This is my native place. I am from Jinji. Actually, this is Jinji Fort. Everybody knows about this place. Actually, so this place is prone to a drought prone area. Actually, generally. So our forefathers, our kings are very, very clever. You can see this a small pond. Okay, so they have diverted all the drainage water from the hills and through a channel, and it will link up with this flood pond, so that if you go every time, you can, any time of the year, you can find some water over there in this area, so that always water is coming inside the area. And they have a small structure like this. This is what we call as granary. Actually, they used to store food over there. So for any drought condition, what you need is food and water. So they used to keep storage of food and water, so that the village people will be saved. So that's what our kings have done an excellent job. And similarly, the same fort, there's another structure over there in the top. Actually, the same area, if it is undergoing some flood, so the food and water, you cannot come and eat. So the kings can take the food in the top of the area, and they can use the water. There is a small pond over there in the top of the area. They can use that. And another, like, in the same Sinji fort, actually, we have a 3 fort. These 3 forts are connected. You can see the structure. It is not a single rock. The whole area is called spheroidal weathering. So you are not able to do any kind of, construction over there, but they are constructed nicely in the top of the, top of the hill. They constructed a fort, and they have connections also. Like, nowadays, like if you go and see, like, from one port to another port, you can see from other port to see Raja can see Rani, Rani can see the other Raja. So like that, they have a system, like, nowadays everybody be talking about optimum route analysis in cell phone towers and other things, like, the visibility. So those kind of information is already done by our kings and forefathers. This they have done, 500 years, 600 years before itself. And this is another kind of structure, temple architecture from, in most of the temples in India. You used to see, like, this is kind of area people they used to for incident command system. So when there is a war is happening or any kind of disaster happening, people, they used to assemble over there. They used to talk, and they used to give a warning over there, and all communications can be given over there. So if you go and sit and talk from one corner to another, it will be visible, it will be audible to this kind of area. So people, the kings and forefathers, they used these areas as a incident command system areas. And this everyone knows about Tanjavur. What I'm going to talk about, this is like, this is the river which is flowing. Actually, this is the original river. Actually, they cut the river, they constructed the temple over there. And even still now, it's more than 1,000 years old. Still, none of the flood water goes inside the temple. Such a way, our forefather, they designed the river water system, drainage system in India, in Tamil Nadu. And this another one, everybody knows about Rameshwaram. Actually, Rameshwaram temple is in the coastal area. There were around 1,000 cyclones were crossed over there in Rameshwaram, but none of the cyclones were hit over Rameshwaram temple. So why it is? Because of it is aerodynamic. Like you all know about ambassador car. So ambassador car is aerodynamic. For example, the wave will come, it will cross over, but it won't hit the temple because it is aerodynamic structure. It's like sharpened in one edge, so that wind will come and it will hit, but it won't damage the structure. So our forefathers are very clever, and they have constructed such kind of even the dam in Trichy, what we call Kalane. It's a 1,000 years old dam. They constructed the dam over liquefaction prone soil, so that even if you put your leg, it will go inside. But they have constructed a dam over there, and it is 1,000 years old dam. Still, the dam is not or damaged anything. So our forefathers are very, very clever, and they have used our knowledge very wisely. But what we are doing currently, we are having all these techniques, but we are not using currently. So we have to use our transferring our traditional knowledge to traditional and indigenous knowledge with our technology, so we can go for a successful disaster mitigation and management, what we can do in future. And 1070 is our state emergency operation center, and 1077 is the district emergency operation center. You can call this toll number at any time for if any disaster conditions. So 1.34 billion brains, and we have 2.6 billion hands. Our destination is disaster risk-free India. Thank you. Any doubts?
Thank you, sir. It was a great pleasure to listen to this informative session. We learned a lot from you through this webinar, and as well as from your brilliant presentation, sir. Thank you so much, sir. I also take this opportunity to thank you from bottom of my heart for taking time from your busy schedule to be the guest speaker at our league. Thank you so much, sir.
Thank you.
Participants are invited to post their questions in chat box. Thank you. Sir, we have a lot of questions in chat box.
Okay. So somebody is asking, where can we obtain those forms for identifying the damage? It is available in NDMA website, National Disaster Management Authority website. You can search for rapid visual screening. You can get the data. I think Archana madam asked this question. And Deepika she asked about what increased disaster risk. How do we can reduce the disaster risk? See, increasing risk is like unplanned colonization or unplanned infrastructure without considering any hazard. Actually, we do not know. For example, many other people, if you are going for a construction of a building or a construction of any structures, so we need to know where it was. Actually, many of the people, they do not know. It may be once upon a time that area may be a pond area. Without knowing that, they go and construct a house over there. Because of that, the flood water comes inside. Or they may not know it may be a river bank. People, they do not know actually exactly, but they should have some basic idea of geography before going for any kind of construction. So that will increase as the risk, because you are going to construct a house on a highly flood prone area. It means flood will come, because nature doesn't care about anybody, right? It will come on their own. So if you want to disturb a nature, then obviously it will hit on you, right? So that's why the increasing risk is mainly due to the if you are not listening to nature, then it will increase the risk. And what is the hazard and disaster? So good question actually. Hazard is a phenomena. So when it involved people, say example I told, like fire. When in a building it catches fire, when nobody died, then we'll call it as a fire hazard. Because of the fire, many people, if they died, then it will become a fire disaster. So this is the difference between fire and hazard. And effects of disasters is loss of lives, loss of livelihood, we have so many impact. Like already we are seeing because of this COVID, right? So loss of lives, lot of economic loss, psychological disorder, and loss of damage due to other disasters. So impact on human life. So many things are there. And what are the will hazard always cause disaster? Not necessarily. Hazard will be there, but if you are not properly manage the hazard, then it will become a disaster. And somebody is asking, frequency of disaster at present comparatively higher compared to our former times, especially we are facing ultimately rains and flood Chennai city too. Could you please state on the reason for it? Okay, so one thing is the climate change we all talk about now. That is one thing. The frequency of disaster present is comparatively high, but I'm not sure whether it is really high, because we do not know what has happened in 200 years before or 300 years before. Whether we had those kind of situations over there, then why our forefathers, they have took so many care on that. I have shown some of the structures, like so it may be in those days also we have a kind of flood and cyclones. Other thing, it might be heat over there, but we don't have a data on that actually, because in the olden days data we don't have properly recorded data. If we have those data, maybe we can tell, like now we have increase of disaster. But one thing what I can tell you right now is increasing of disasters is because of the climate change. That's what mainly many scientists we are discussing right now on that. And somebody is asking, it is very expensive to construct earthquake resistant buildings. It's not expensive. That's what I told. It is only 3.6%. Okay, so it is not necessary we have to do for all the buildings. So only the buildings it is necessary. It is in high earthquake prone areas only we have to do the earthquake resistant. Otherwise we don't need. We have to only teach the people how to do, how to evacuate or how to manage the earthquake. So those kind of information we can give. That is enough for us. We don't need to go for all areas to earthquake resistant. It is not mandatory. And what are all the concerned challenges or areas improvement in disaster? So that's what I told in improvement. Mainly, we are doing everything in short term, right? So we have to have a plan in long term, right? That is the main problem what we are facing currently is in India. When something happens, immediately we go and do rescue operation, we do distribute relief material, we give money people. Say some building collapse, some school building wall collapse. Immediately what we are doing? So you demolish all school building walls, which is old. That is not the right way actually, because what we need to do is like this should be there every time, right? We have a different committees are available, so these committees should inspect time to time. So see, if some school children die from fall out from the bus hole, then immediately they will do all inspection of bus. It is not like that. So when school starting, you have to inspect the school buildings, you have to inspect the buses, you have to inspect the bus route, you have to inspect the school roads, everything. It's not like one time, right? Somebody dies, we are doing. Somebody dies, we are doing. It's not like that. We have to do when somebody dies. It should be a regular process. It's like our day-to-day life, like regular thing what we are doing in our life. So we have to add disaster management also part of it. So then only it is possible. And what is the best action to be taken by the government to risk effect? So that's what I told. Like nowadays, like we have a lot of mitigation, structural, non-structural mitigation measures are taken place in government. Actually, already our government is doing. Every district they have to give the disaster management plan. In that, they have to identify top 10 disasters of the particular districts, and they have to reduce. Say, if I identify top 10 disasters in my district, say example, drought is one of my district, major disaster in my district. So what I have to do is, next year the drought should not be there in this. So such a way that I have to manage the drought, so that I have to arrange, widening the river, desilting of the lakes, everything I have to do, and based on that, my district will be free from drought. So like that. So this is a kind of thing already government is working on. And okay. I think I have answered all the questions. Yeah, I will share the PPT with Archana madam. No problem. You can make use of it. Madam can share with all the participants. No problem.
Okay, sir.
Okay, so you can, if you have any doubt, I am in Facebook. So all my information I can put it in Facebook. If you want, you can. This is my this thing. Ganapathy. If you search Ganapathy Pattukandan, you can. I am there in Facebook, and my phone number also I'll give you. 984177199. This is my phone number.
Okay, sir.
So anytime you can talk to me if you want to do any projects or any help, students. If you want to do anything related to disaster mitigation management, you are most welcome. We are ready to help, and all my information will be available in Google. If you put Dr. GP Ganapathy in Google, so all my informations are available. You can check about me. And if you join in Facebook, every day I put a lot of disaster-related information you can get.
That's great, sir. Thank you, sir. Sir, one last question. Can you please list out few important roles of students to help the nation in reducing the impact of different disasters?
Yes. So main thing is students are the backbone. So that's why we used to teach disaster management in all undergraduate level. Currently, we are doing it's a part of the curriculum. So one thing what you can do it at your level is dissemination, disaster awareness campaign. For example, recently we had a shaking in Pernambuco. Actually, this is a place near Vellore district. You might have seen in TV. So I myself visited with the collector, and we have inspected that area. While we are inspecting itself, there was a earthquake happened. It's not an earthquake actually. There was a shaking. So we are monitoring that area currently and doing some research on that. But most of the time, whenever we go to any disaster affected area or earthquake affected area, immediately these people, they don't have a basic knowledge on that, and they will come and ask so many things, and so we need to make aware the people. So we have to explain what is that and what is happening during that time, what kind of measures government will do. So every time earthquake is not predictable. For example, people, they do not understand. They will ask when there is going to be a next earthquake, and what government will do, whether I will get another earthquake, whether I have to go inside the room house or not. So many questions people they used to ask. So the thing is, the ignorance is one thing, and another thing is handling village people is very, very difficult. Yes. Maybe you have a lot of social department people, so you can go and make people to aware about the basics of small things. I have talked about today about more of technical things, but what I want to students can do is students can go and convey some small things hygiene, yes. Wash, water, sanitation, hygiene, about disaster, what they are living. If there is a flood happens, what they have to do. See, I'll give a best example. I was in Bihar actually. When I asked a question about a fifth standard girl, still I remember her name, Beauty Rani, in Bihar. She used to tell what is all do's and don'ts, everything about earthquake. When I say what you will do when there is earthquake, immediately she started demonstrating. So only because those areas in Bihar are highly earthquake prone and flood prone areas. So the government, they teach us all kind of measures. So here, today's lecture, I am not teaching all these do's and don'ts. Everything is it's a very basic level. It is available in internet. What I taught is mostly on what are the new technologies available. All these things I have taught in today's class. But basic things are there. It is available in internet. You can download from our NDMA web page, and SDMA web page is available. So those kind of information anybody can read and easily understand. So those kind of information should be disseminated among the people.
Okay. Okay. Thank you so much for clarifying all our doubts, sir.
Thank you.
I invite G. Ramya to propose the vote of thanks.
Good afternoon, everybody. It gives me immense pleasure to propose the vote of thanks on this occasion. I take this opportunity to thank Dr. G.P. Ganapathy sir, Professor, Center for Disaster Mitigation and Management, Vellore Institute of Technology, Vellore, our resource person for the day, for giving us informative and useful talk on disaster risk reduction and challenges. Sir, I'm sure your talk has enabled our students to have a better understanding on the topic, and it will definitely help everyone at all emergency circumstances. I profusely thank our chairperson, Mrs. Chandra Devi Tanikachala ma'am, our principal, Dr. S. Kodai ma'am, our principal in charge, Dr. D.B. Usharani ma'am, for their constant support and encouragement. I thank the Dean of Students and the head of all departments for being a great source of encouragement and support to us. I thank all the members of faculty who attended the webinar today despite their busy schedule. Our special thanks goes to Dr. Kautarajan sir, Tamil Nadu Open University, and Dr. K. Saraswati ma'am, Department of History, Ethi-Shakthi College for Women, for helping us to arrange the resource person for this webinar. I also take this opportunity to thank Dr. Archana Soman ma'am, Faculty Coordinator, Disaster Mitigation League, for her constant support in this endeavor. My thanks are due to the members of Students' Union 2021 to 22 for helping us with the circulation of our invitation and circular to everyone. In a special way, I thank Ms. Sri Dhanvi of 3rd BCom for being an able and wonderful co-representative of the League. I also thank Ms. Rajalakshmi T of 3rd BA History for her constant support in the preparing of e-invite. Last but not least, I thank all the student participants for their active participation and patient listening in today's webinar. I extend a special word of thanks to the technical team and the support staff, without whom the program wouldn't have taken place today. Thank you all. Hope you had a fruitful session. Good day, everyone. Thank you. Thank you, sir.
Thank you.
Sir, thanks a lot, sir.
Thank you. Can I leave?
Yes, sir, please, sir. Thank you, sir.
Thank you, sir.
Participants, thanks a lot, especially those who had shared questions. A special word of thanks from me and from the league members of the Disaster Mitigation League. Okay. So thank you all for the active participation. Bye.
Thank you, ma'am.